of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
The most bizarre photo ever taken with the James Webb Space Telescope has been made public by NASA. 3 years ago, the James Webb Space Telescope was launched almost 1.5 million kilometers from Earth. In search of far-off celestial planets, this telescope circles the Sun. It just took an image that curiously seems familiar. It was even dubbed the penguin and the egg by the experts. But really, what are we even examining here? Is it a nebula, a constellation of stars, or something else entirely? This video will provide us with the answer. James Webb Telescope We have traveled to unfathomable regions of the cosmos because of our insatiable curiosity and want for knowledge. Even though we are unable to travel, we have begun to build telescopes that are capable. The most potent and ambitious of them all is the James Webb Space Telescope. James Webb is more akin to a time machine, a cosmic investigator, and a portal into the most profound mysteries of the cosmos. However, how did this amazing concept come to be? Let's go back to the early 90s. Scientists dreamed of a successor telescope that could look even farther into space than the Hubble Space Telescope could, after the latter transformed our knowledge of the universe. The James Webb Project was founded as a result of this idea, and its main objective is to study the earliest galaxies to emerge following the Big Bang. Yes, it is correct. The architecture of this telescope allowed it to peer back more than 13.5 billion years. It was not easy to build the James Webb Space Telescope. Decades of planning, developing, and overcoming numerous obstacles were required. Official work on the project began in 1996 and involved NASA, the Canadian Space Agency, and the European Space Agency. To make this amazing telescope a reality, these groups combined their knowledge, resources, and technological know-how. The building of the James Webb was as remarkable as it got. The telescope is made up of several important components, each designed to play a specific function in this cosmic mission. To truly comprehend how this telescope functions, we must become knowledgeable about its many components. Let's have a peek, then. The primary mirror is the most crucial component. It is the main attraction. The main mirror is a large 6.5 meter wide mirror composed of 18 segments that are hexagon-shaped and have a thin layer of gold covering each one. The purpose of this mirror, the biggest ever sent into space, is to gather dim light from stars, planets, and galaxies far away. The James Webb Space Telescope's large size and accuracy enable it to observe objects billions of light years afar. The telescope then features a sunshield. This section can be thought of as a massive cosmic sunscreen. The 5-layered sunscreen, which is roughly the size of a tennis court, was made to shield the telescope from the heat and brightness of the sun. To reflect sunlight, each layer is composed of a unique substance called captain that has been coated with silicon and aluminum. The telescope's temperature is maintained at about -233 degrees Celsius by the sunshield. Because it permits the telescope to see weak infrared signals from the distant universe without interference, this temperature level is significant. The telescope features an integrated science instrument module after that. The 4 primary scientific instruments that do all of the work are housed at the ISIM. These consist of spectrographs, the mid-infrared instrument, and the near-infrared camera. When these tools are used in tandem, the light gathered by the mirror may be captured and analyzed, enabling researchers to investigate everything from star formation to exoplanet atmospheres. A bus for spaceships is also present. The core of the James Webb is this. In addition to providing structural support for the telescope, it houses the technologies that power and manage every aspect of its functioning, including its data processing, propulsion, and communication. This may be thought of as the nervous system of the telescope, ensuring proper operation while it is floating a million miles away from Earth. It was expensive to create the James Webb because the entire construction is too complicated. The project's overall cost skyrocketed to around $10 billion. Everything from the first engineering and designs to the launch and continuing operations was included in this price. Despite being among the priciest scientific equipment ever made, its capabilities make it well worth the money. Given all of these amazing qualities, one may question how it functions at all. How do all these components work together to reveal to us the millions of kilometers distant cosmos that exists? The science that underlies it. Although the James Webb Space Telescope is a gigantic space camera, it is not able to take images in the same way as our conventional cameras. Rather, it gathers light from locations billions of light years away, the most remote parts of the cosmos. But how exactly does it accomplish that? The telescope uses infrared wavelengths to catch light, not visible light like human eyes do. Why is infrared used? Since the things it is observing, distant galaxies and stars, for example, are so far away, their light has expanded into the infrared region. Through the use of its enormous, gold-coated mirror to gather light, the James Webb is able to see objects that are not visible to human vision. The scientific equipment on the telescope then process the data and produce pictures from this light. Now, be aware that those breathtaking photos taken by the James Webb Space Telescope are not, at least not inherently, colored. Since the light the telescope catches frequently is outside of the visible spectrum, it is invisible to human vision. Here, the idea of wavelengths is crucial, so pay close attention. Different light wavelengths correlate with different hues. For example, the wavelength of red is longer than that of blue. Scientists use the equipment on James Webb to collect light in a variety of wavelengths, and then they apply colors to these wavelengths to produce the pictures that humans view. However, these photos aren't ready for Instagram when they emerge out the telescope. They must be improved. In this procedure, data from several exposures are combined, and any noise that may have affected the image is cleaned out. It's a laborious and demanding task that calls on both human skill and computer algorithms to ensure that every hue, every detail, and every star or galaxy are precisely delineated. Finally, we are left with astounding pictures that are not only stunning to look at but also teeming with scientific data. Now, recall our statement that the James Webb Space Telescope would facilitate Big Bang observations? What is the real meaning of this? How is it able to see back in time? The Big Bang, which occurred around 13.8 billion years ago, marked the beginning of the cosmos. But we are not examining the explosion per se. The first galaxies and stars that emerged a few hundred million years after the Big Bang are what James Webb is seeing. This has mind-blowing scientific implications. We are effectively gazing back in time when we examine distant galaxies because light travels slowly. The age of the light we see increases with object distance. Thus, light that has been traveling for more than 13 billion years is captured when the James Webb Space Telescope takes pictures of these old galaxies. This provides us with an insight into the early cosmos, a time that we have never been able to examine in such depth before. This is amazing, is it not? Would you want to view the first photos taken by the James Webb Telescope? The original pictures on December 25, 2021, the James Webb Space Telescope was launched, making history. Following several decades of preparation and several obstacles faced, the globe at last saw the launch of this groundbreaking telescope into orbit. How did it get there, though? The European Space Agency donated an Ariane 5 rocket for James Webb to go on. Located on South America's northeastern coast, the Guiana Space Center in French Guiana is where this rocket took off. There was no margin for error because this was a crucial moment. Thankfully, the launch proceeded without any problems, setting the James Webb on its unique journey. The telescope was intended to reach a unique location in space called the Second Lagrange Point, or L2, rather than Earth. This point is situated in the opposite direction of the Sun and around 1.5 million kilometers, or a million miles, from Earth. However, why did we select this point? As you can see, at L2, the gravitational pull of the Sun and Earth balances the orbit of James Webb. As a result, it was able to maintain its position while using little fuel. This viewpoint offers a clean, unhindered vision of the universe with no interference from Earth's atmosphere and heat, making it ideal for a telescope like James Webb. The James Webb Space Telescope has a number of important deployments to finish after its successful voyage to L2. In order to cover the telescope's equipment from the heat of the sun, its gigantic sunshield had to unfold precisely. It was an amazing and nerve-wracking procedure to watch the mirror precisely unfold and align. The telescope was prepared to begin its mission once everything was in its proper location. NASA originally unveiled the breathtaking photos taken by James Webb in July 2022. The outcome was quite remarkable, and the wait was ended. The now famous Deep Field View, which displayed a variety of galaxies billions of light-years away, was one of the first pictures to be made public. The Webb's first deep field photograph provides the clearest and deepest infrared picture of the far cosmos ever taken. In essence, we are peering back in time and viewing galaxies as they were only a few 100 million years after the Big Bang. We are talking about light that has traveled for nearly 13 billion years to reach us. The Southern Ring Nebula, a cloud of gas and dust encircling a dying star, was visible in another picture. The last phases of the star were visible in striking clarity because to the image's capture of the nebula's fine characteristics. A stunning picture of Stephan's Quintet, a collection of 5 galaxies interacting with one another 290 million light-years distant, was also taken by James Webb. Indeed, these photos are amazing, but they also contain a wealth of scientific information. These make it feasible for astronomers to investigate in hitherto unattainable ways the genesis of stars, the development of galaxies, and the makeup of far-off celestial objects. The amount of detail we are witnessing is astounding. The James Webb Space Telescope can see past gas and dust clouds that would otherwise block our vision because of its capacity to detect infrared radiation. This explains why portions of the cosmos that were previously concealed from us are now visible to us. However, weren't there already existing telescopes? Why was it that these breathtaking vistas eluded the Hubble telescope? William Webb against Hubble. The Hubble Space Telescope and the James Webb Space Telescope are the greatest space telescopes available today. However, what is the comparison between them? Why is the James Webb superior? Let's start by discussing the variations in their technology and design. Since its 1990 launch, Hubble has spent more than 3 decades producing breath-inspiring pictures of the cosmos while orbiting 547 kilometers above Earth. While Hubble can also record some infrared light, its primary wavelengths of observation are visible and ultraviolet, which is similar to human vision. We now have iconic pictures of the universe thanks to it, including faraway galaxies and the pillars of creation. However, the James Webb Space Telescope was built to look at the cosmos via the infrared spectrum, which aids in our understanding of the distant past. You already know why it does this via infrared, though. Indeed, the light from the first stars and galaxies has been stretched and moved into the infrared region due to the universe's expansion. The gigantic 6.5-meter gold-coated mirror of James Webb was designed with this pale, stretched light in mind. This enables it to observe features and structures that Hubble is unable to detect by peeping through clouds of cosmic dust. The locations of these telescopes are another significant distinction. James Webb is orbiting the Sun at a location known as the second Lagrange point, which is around 1.5 million kilometers from Earth, while Hubble is orbiting Earth. James Webb's equipment remain cold in this location because they are shielded from the heat and light of the Sun and Earth, which is crucial for his infrared measurements. Conversely, Hubble's observation time and capabilities are limited by its need to contend with intermittent sunlight and earthshine. Why didn't we just keep using Hubble, you might be asking yourself. Why even construct the James Webb? What we hope to see is where the solution resides. Although Hubble has been an amazing instrument for studying the cosmos, it is not without its drawbacks. Its primary wavelengths of observation are visible and ultraviolet, hence it is unable to view the first galaxies that formed in the infrared, which is the range that follows the Big Bang. Furthermore, Hubble's smaller mirror makes it more difficult for it to photograph the faintest objects at very far distances. We required a new instrument to study the early cosmos, one that could see in wavelengths that Hubble was unable to see and reach farther back in time. James Webb stepped in at that point. Since its introduction, it has been taking amazing pictures, but most recently, it caught something so strange that experts around are in shock. This time, what has been acquired by the James Webb Space Telescope? The latest picture, the moniker "the penguin and the egg," refers to the fact that the most recent NASA picture appears to show a penguin playing with an egg. What then are we witnessing here? The penguin and the egg are, in reality, two distinct galaxies interacting with one another. ARP 142 is the official name for them. This image, which was released in July 2024 to commemorate the telescope's second anniversary, shows a remarkable cosmic event that occurred in the Hydra constellation 326 million light-years distant. Penguin refers to NGC 2936, a spiral galaxy that has undergone distortion due to its close contact with NGC 2937, a compact elliptical galaxy that forms the egg. These galaxies have been gravitationally linked together over the last 25 to 75 million years. They are twisting and tugging at each other gently. The penguin's once orderly spiral structure has become more like to a bird, with its spiral arms forming the beak, head, and tail feathers, and its brilliant galactic centers serving as the eye. In the meanwhile, the egg hasn't altered all that much, which is indicative of its older and more reliable character. A blue haze around the galaxies, which is composed of gas and stars pulled apart by their interaction, was also recorded in the photograph. Because of this interaction, the penguin has seen bursts of new star creation, particularly in the areas of its tail and beak where the gas has been squeezed. Nonetheless, because the egg has less gas and dust in it, there is less evidence of new star formation. These galaxies are anticipated to merge into a single galaxy during the next few 100 million years as they progressively approach one another. Other galaxies in the backdrop have also been photographed by James Webb. The young galaxy PGC 1237172, which is situated close to the upper right corner of the picture and around 100 million light-years distant, is one of them. Although it is neither the James Webb Space Telescope's first or final finding, it is an intriguing one. What more astounding discoveries has this remarkable telescope made? Additional findings: did you know that some of the first galaxies to form have been found by James Webb? Only a few 100 million years after the Big Bang, some 13 billion years ago, these galaxies were first detected. In addition to researching galaxies, James Webb has produced amazing discoveries about exoplanets, or planets orbiting stars outside of our solar system. Discoveries of water vapor, carbon dioxide, and other chemical fingerprints that point to the possibility of habitability have been made possible by the telescope's capacity to examine the atmospheres of these far-off worlds. For instance, when James Webb studied the gas giant exoplanet WASP 96b, he found unmistakable signs of water in its atmosphere. We're getting closer to finding planets that might harbor life thanks to these discoveries. The capacity of the James Webb Space Telescope to witness the creation of star and planetary systems is another amazing accomplishment. Through observing these areas, like the well-known Carina Nebula, astronomers have learned more about the formation and evolution of stars and the planets that orbit them. Additionally, the James Webb Space Telescope has shed light on how supermassive black holes behave. Through the telescope's observation of the cores of far-off galaxies, the impact of these enormous objects on their surrounds has been identified. For instance, it has recorded proof of the strong energy jets that black holes release, which control the expansion of galaxies. We can better comprehend the intricate link between black holes and the galaxies they inhabit thanks to such data. With much optimism, the James Webb Space Telescope's future seems quite promising. Studying the first light to be emitted after the Big Bang by traveling into the cosmic past is one of the main objectives in the ongoing exploration of the early cosmos. New insights on dark energy, dark matter, and the underlying processes that produce the universe might be obtained from this research. In the realm of exoplanet research, the James Webb Space Telescope is predicted to yield important new findings. A wider variety of exoplanets, including rocky planets the size of Earth that are in the habitable zone of their stars, are of interest to astronomers. By doing this, the telescope could be able to find worlds where life is possible. Additionally, biosignatures or proof of life on an exoplanet are being searched for using this telescope. It's like it's on a search for extraterrestrials. Aside from this, James Webb will keep researching the genesis and development of planetary systems, galaxies, and stars. The way we used to view the cosmos has already been altered by the James Webb Space Telescope. Its upcoming discoveries appear to be just as revolutionary. Please like this video and subscribe to the channel if you would want to see more funny videos. We have a lot more of them. I appreciate you seeing.